Thanks everyone for joining. My name's Chris O'Hara. I'm the technical coordinator stroke secretary for the InstMC Northwest section. My function within the committee is to arrange technical talks for or from various specialised engineering companies, anything to do with instrumentation and control, which then get recorded and go on YouTube. But we try and do it every month. But this month, the month of November, has been set aside for the Early Career Engineer Award, which in 2025 was awarded to Azizeh, who is kindly come online today to present her workings or project, which made her the winner of the 2025 Early Career Engineer. So yeah, just for information, this presentation is recorded. It is saved and put on the InstMC YouTube channel at a later date for future viewing. It also allows our membership to access the presentations as and when they are available. So yeah, I'm going to hand over to Azizeh. She's going to run through her project. We will open a Q&A session at the end, but if you've got a burning question, feel free to raise your hand and we'll also try and get round to you. Can I just ask everyone to mute the mic, please, apart from Azizeh? And once again, thank you, Azizeh, and off you go. Cheers.
Hello, everyone, and thank you for attending to this presentation. My name is Azizeh Lotfivand, and very welcome, everyone. This presentation outlines my contribution to a biomethane project that showcases innovation in measurement, control, and automation. I want to share my screen to see my slides. This is the presentation for Early Career Engineering Award in 2025 on standardized control software architecture for biomethane gas entry units to improve reliability, maintainability, remote diagnostics. So the project is for biomethane gas entry unit, GEUs, and the company is nZero Group. And this is my contribution to a biomethane project that showcases innovation in measurement, control, and automation. I want to have an overview on project. The scope is interfacing with upgrader plant. Upgrader plant is a plant that upgrades biogas and send to us, purified biogas and send to us, and gas entry unit is a gatekeeper. That gatekeeper is critical for gas quality assurance. It integrates sensors, control logic, and communication with grid operators to ensure safe and compliant gas injection. And in our GEUs, we ensure that gas quality and pressure compliance going to gas network is met, and measures and analyzes gas and energy values. We report the volume and energy content for OFGEM. OFGEM is Office of Gas and Electricity Markets, as you know. And we control our ROV is remote operating valve that is controlled by network whenever it is required. And manages flow to the gas grid and includes safety interlocks in software and control systems. We have GSMRs. GSMRs is gas safety management regulation. And fire and gas panels, GSMRs, H2S, O2 sensors, and H2O sensors included, and gas detectors. And I want firstly to show you some pictures of our project. As you see, it is our analyzer rooms. In our analyzer rooms, we have sometimes one GasPT, sometimes two GasPTs to make sure that all our measurement is in scope. GasPT means the same as gas chromatography, but it is faster than that. And it measures gas composition, the important gas composition, not all of them, but important part of gas composition. And it includes H2S sensors, O2 sensors, and H2O sensors, and FISs for measuring the flow of the level of our flow. Next part is gas room. In gas room, we have two lines in two directions. One is going to gas to grid. If everything is in spec, we send gas to grid. But if some of them or one of them is not in spec, we send gas to flare. You can see here, and you can see the vaporizer. We need to warm the propane up to inject to our gas, which CV is not in spec. I mean that CV should be nearly 39.5, nearly that much. If it is not in that range, we need to add propane for that. I will explain later. And this is our control room. In our control room, we have the main part is PLC Step 7 1500 series with its IO modules and its communication module for communication between us and RTU telemetry, because we are communicating with RTU, with Modbus RTU. And we have Adams IO module here, and we have Flow Computer, Flow X here, and industrial PC here, and we are using barriers for our IO modules, IO cards, but recently we are using ISIOs instead of having loads of barriers. And we have other barriers for communication with flow meters. We have two flow meters, one for inlet flow meter and second one for fiscal flow meter. And we have HMI panel here. And if you see, we have CTOP UPS here, and that's it. And Lua controller for injecting odorant to our gas. For next one, we have, I'm responsible for designing and implementing the automation and control systems, integrating with instrumentation and SCADA interface. So I need to do configuration of instrumentation like flow meters, ultrasonic flow meters, GasPTs, flow computer. Our flow computer in this project is FlowSec-X. Gas chromatography in some cases, not all cases. Sometimes we use GasPTs instead of gas chromatography. And Adams unit, Adams IO module, DANINT software, and I'll explain about DANINT a bit further. And I developed PLC logic and VNCC HMI, collaborate across disciplines for commissioning. We need to collaborate with other disciplines like process team, like ECNI team, and Atlas service team, commissioning team. The next one is I need to tell about system architecture. As I told you, we have Siemens S7 PLC 1500 series, VNCC Advanced, and recently we switched to VNCC Unified HMI. And we have two FlowSec USM, inlet flow meter from upgrader, injecting flow to us, and fiscal flow meter. We have 6 FlowX flow computer, GasPT analyzers, or gas chromatograph, or one GasPT and one gas chromatograph in some of GEUs, depend on the customer asking. Safety system includes H2O, O2, and H2S sensors, gas detectors, fire and gas panels, GSMRs, I mean, that triggers automatic shutdown in hazardous condition. Gas odorized system, propane vaporizer, and we need to ensure safety, compliance, and protect equipment. And we need to keep all comms, not to lose the comms. We have all kind of comms like Modbus TCP, Modbus RTU, or point-to-point to PNP coupler. And we have Adam 5000 TCP unit, even router to monitoring remotely. And recently we want to add IIOT platform, Industrial Internet of Things. So it combines industrial automation standard with modern SCADA and telemetry for real-time monitoring and remote operation. The system continuously monitors key gas components and environmental hazards. We always keep monitoring the WOBE, CV, and if threshold are exceed on any sensor, or if an alert is received from the fire and gas panel, an automatic shutdown is triggered to ensure safety and protect personnel and equipment. And for measurement and control, accurate flow and energy measurement is key. As you know, calorific value, CV, is a measurement of the energy contained within a gas and is depend upon the composition of the gas. The CV is used to calculate the energy that may be released when a known volume of gas is completely combust under a specific condition. And we used ultrasonic meters and real-time analysis to control output safety and efficiency. So we have ultrasonic flow measurement, CV measurement, WOBE index measurement through via GasPT or gas chromatography. And we have a CV control with PID-based, and we control propane control valve to inject propane to meet the scope of CV. And we are using ramp function to mitigate the slew rate and to mitigate the jump of the signal of propane injection to have propane control valve smoothly inject propane to our gas grid. And we have remote diagnostic via telemetry. We send online important things, important signals to telemetry via Modbus RTU. And we are using two GasPTs, mostly two GasPTs, fast GasPT and off-them GasPT. We have fast GasPT updating in 8 seconds and off-them GasPT updating in 4 minutes. Which we need to have bias correction to apply to fast GasPT for last 10 values we getting from fast GasPT, and we smoothen the previous measurement things from fast GasPT to be as much as near to off-them GasPT. And if both of them are not near to each other, we have some limits for that, some threshold for that. In case of discrepancy, we raise alarm and the plant will go to reject mode. And innovation for this project is we introduced custom delay logic in PLC to mitigate pressure surge during valve transitions, an innovation that improved stability without physical modification. As you know, modification in software is more important than mechanical things. it has more cost for us. Flow and pressure simulation meant we could test the system before gas was available, catching issue earlier in the process. So in pre-FAT time, we one by one we simulate all alarms and without gas, real gas, and we make sure everything is in order. So we have custom delay logic to prevent pressure spikes, and we have a software solution avoided costly hardware changes, enhanced system stability, and the custom test mode implemented in PLC and HMI. Alarms, we simulate alarms without real shutdown, real gas, and improved training, commissioning, and fault diagnostics. The other thing is structured tagging and modular code. As you know, using modular and structured code made the project easier to scale and maintain while reducing engineering time on future systems. So we have some pre-made blocks, for example, for scaling AI and analog outputs, AI alarms, digital alarms, or remaining time for some sequences, because we have 8 steps for going the gas to grid, and the operator needs to know how much time we have to get to the next step on HMI, and we have pre-made ready to use byte swap or pump control, bias correction, propane density, convert ppm to milligram to cubic meter for H2S analyzers. And we have, in this case, we have faster integration and future scalability, easier maintenance and troubleshooting. When one alarm raised, we easily can find the reason of alarm, and directly we can remove it. The other one is embedded interlock matrix. We have some software-based interlock logics, transparent trip cause identification, and paired with clear HMI messaging. So we need to clarify everything for operators on site or commission team or service team to make them aware of the plant behavior. So integrating interlock logic with visible HMI message helped operators quickly understand fault and respond appropriately. And we have live trends and visual diagnostics. Operators could visually track process performance, which helped identify unusual trends or issues in real time. So we have some real-time trends, some key real times like pressure, temperature analyzers like GSMRs, and it lets the operators or service people to spot on the real-time issues or the things, the process behavior in past days, past time, and HMI-based visualization of process behavior and enable proactive monitoring. And redundant communication logic. We integrate some heartbeats for every external equipment. For example, we have heartbeats for upgrader PLC. We have heartbeats for RTU telemetry unit and flow computer. Everything we need to monitor, we have communication through. So in this case, we prevent unnecessary shutdowns on telemetry loss and increases uptime, decreases downtime, increase reliability of remote monitoring, and making grid entry unit to be more efficient. And the system continued to run safely even if remote telemetry was interrupted, avoiding downtime and unnecessary trips. We improved diagnostics using detailed HMI visual, which helped operators identify issues faster during commissioning and operation times. We developed detailed HMI for fault tracking, integrated test modes for commissioning, and enabled fast issue resolution, creating faceplate for most of instruments. So it makes much easier for next projects that are similar to our project to use faceplates anywhere it is needed according to customer asking. Because I had 7 projects up to now, and none of the projects are all the same. So we need to have the original one the same, but we need to change, customize our HMI and code according to customer need. And certified integration with DANINT. I earlier explained about DANINT, and I want to say that DANINT is a certified middleware package essential for data collection and audit compliance in biomethane sites. Although it is complex to configure because it is an old software, and it consists of I think 50 files, batch files or DAT files. We need to configure them. I developed a structured configuration approach to streamline setup across multiple devices. This ensures accurate logging and faster regulatory approval. So certified middleware used to receive and route signals from our main devices like GasPT or GC, flow computer. We need to get important values from flow computer, lively, volume, energy, pressure, and temperature. And we need to know if there is any system 1 alarm, important alarms. System 1 alarm includes some important alarms. We need to promptly shut down the system according to the alarm type. If it is critical, more critical, we need to send plant to off mode or reject. Whenever the alarm cleared, the plant will go to grid promptly. And ADAM-IO modules, the ADAMS-IO module is a digital and analog inputs which carries on our important things like temperature, pressure, and for energizing our solenoid valves to check our GasPT in piece of time. That we need to check valid our GasPT at least once a month or once a week. The configuration is different, and at that time DANINT will energize our solenoid valve to get the some calibration gas and compare it with sample gas and fail or accept past the GasPT. All these are done by DANINT software, and supports off-gem compliant data acquisition. DANINT software supports off-gem compliant data acquisition and enables safe and certified gas-to-grid injection. So in IIOT Security platform, we are using, we intend to use it in next project. We are using end-to-end encryption is achieved by using MQTT cloud-based for secure data transmission, and we are using the AES 256-34 encrypting stored data, ensuring confidentially and integrity both in transit and at rest. So we can, it gives off the opportunity to real-time monitoring or customizable trends, active alarming records, and we have records from IntelliGuard, IIOT, and performance reporting, multi-site management, and it could security architecture. nZero gateway pulls field devices, telemetry sends securely over MQTTs, data processed and stored in the cloud. And that's why it decreases our unnecessary shutdown time, and it secures end-to-end encryption and mutual authentication and continuous monitoring. So it will decrease our maintenance time and prevents unnecessary shutdown and increase uptime. And the outcomes of the projects is we successfully gas to grid inject for about 5 GEUs for myself, and the others are on the stage of SAT, and increased control reliability, lowered risk of system trips, decreased downtime, and ultimately the system goes live successfully and met all performance criteria. And the clients praised its reliability and user-friendly interface. And the most important things are operator confidence and satisfaction. Skills needed to do this project from my side is it helped me to apply and grow my skills in real-world automation environments, especially under tight deadlines and under tight pressure on troubleshooting on FAT, SAT, or pre-FAT times. And I need to know and improve my skill on PLC and HMI development. For future scope, we are already applying these practices to new sites. The diagnostic approach is being shared across projects. And we need to share design standards across team, and lesson learned in each project across all team includes process team, ECNI team, and service or commissioning team. And at last, I want to share our main screens of HMI to you. As you see, our HMI consists of overview page. It shows you that if it is gas to grid or it is going to flare at the moment, or the main things like propane vaporizer situation, if it is healthy or ready or enabled. It seems it shows our flow control valve for injecting propane to grid. To our gas to meet our thresholds to CV amount, and it shows the main component of gas, C1, C2, C3, methane, ethane, propane, or carbon dioxide or nitrogen, CV, RD, WOB index, sooting index, or ICF. And what is the moisture value, what is the oxygen value or H2S value at the moment, and what is the inlet flow and pressure, inlet pressure or inlet temperature. And so operators mainly use this screen to make sure that everything is in order. The other important screen is is a data screen. Data screen is explaining us the total export gas to network, fiscal flow to the network for today, for up to now, from first day and last day. Because our gas day is changed at 5 a.m. every day, and we need to get data from our PLC, that is are coming to flow computer to most important things. For example, fiscal flow meter or CV, or how much flow we get in the past day, or total from upgrader, or odorant, how much how many grams we injected odorant to our grid. And gas quality, it shows gas quality that is getting from DANINT software, off-gem analyzer, because off-gem analyzer is running through DANINT, and we need to show the data getting at the moment from DANINT. So as I told before, it is updating every 4 minutes. And fast analyzer, if we have fast analyzer, it updates 8 seconds. The same gas components, and H2S analyzer, O2 analyzer, and moisture analyzer. The other main screen is help page. If we have any issue, if we have revert to off, or we have export not permission, I mean gas to reject mode, we need operator needs to know the reason. We included the most important alarms in this screen, so we have the most important that related to shutdown and sending our plant to off mode is included in upper one. So they are alarm latch connected to each of the process. For example, process stop, seaway proving failed, or both propane pumps, because we have 2 propane, duty propane and auxiliary propane pump in our project. And if both of them failed, we need to clear the alarm, and then the operator needs to reset the alarm, which this part of alarms doesn't need to operator to reset the alarm. So the most important, and GSMRs and safety alarms included in this part, and the other less important alarms included in export not permitted alarm. So in right one, we need to have all in green to let the gas injected to grid, and we need to have a green tick here, and everything is meet. For example, DFO allowed, we need to get this bit from RTU that we are allowed to inject the gas to grid, or upgrader is sending flow to us, gas to us, or CV in spec, GSMR in spec, and operating mode is push button is operating mode button is pressed by operator. So next one. And another thing we need to do is we need to check all our GSMRs, I mean H2S and O2 analyzer, in a specific time of day to make sure that our analyzer are healthy. For example, at 11 o'clock or 8 o'clock every day, we automatically run calibration gas and sample gas to our GSMR, and make sure that our GSMRs are in spec. And if they are not pass the daily check, we will kick the system off. Thank you so much for your notification, and I'll be very happy if you have any question, or if you have more question, I shared my email address and you can send me email. Thank you so much.
Thank you, Aziz. That was a very interesting presentation, and it obviously appears you've put a lot of dedicated hours and effort into your work. So, you know, very well done, and congratulations on winning the award for 2025. Does anyone on the call have any questions for Aziz?
Thinking, Chris, can I just hello everyone, Dave Green. I was the chair of the Institute local section up until October. John Alexander of Tyson is now the chair. Just a thank you to Azzy, and congratulations again. We've obviously met a couple of times since the award, and it just really shows that what engineering talent we've got in the Northwest, and congratulations to you. This is the second year we've given the Early Career Engineer Award, and we recognised locally that we give university awards, and we have done for a very long time, and we now wanted to reach out to the working engineers of the Northwest to recognise the talent we've got in the Northwest in engineering, in measurement control and automation. And it's just a plug, really. We've now got the 2026 award live for applicants. Be them in Tyson or other companies out there. We want to thank ITI Group for sponsoring the 2025 award. Hopefully they'll sponsor 2026 as well, but we'll see. But they're now live. If you check out our website, InstMC.org, and look for Central Northwest section, you'll see the details of how to apply for 2026. And we're also, for the second year in a row, also have an Apprentice of the Year award as well. So for any apprentices out there as well, that one was sponsored by Capula in 2025, and again we're looking for apprentices in 2026 as well. So they're both live. You know, nominations. Please tell your friends. The criteria, as Azzy will tell you, is not onerous. We want someone to come along with some innovative project with regards to how they've used either existing technology in a new setting or new technology, and be within 10 years of being in the automation control, measurement control and automation domain. And be that for a changing career or be that straight from graduation, we want to hear from you. So yeah. So that's where we're at.
Thanks for that, Dave. Just to chime in on that. Yeah, sorry. I've just linked the website into the chat, and I've also put the email address that people can get in touch with if they're interested. Just going forward. Yeah. But yeah, thank you very much, Azzy. That was fantastic.
John. Yeah, thanks, Azzy.
Good stuff. Well, thanks, John, and thanks, Dave. And once again, thank you and congratulations, Aziz. We'll close the presentation.
Thank you so much, everyone. Thank you so much for attending.
Bye-bye.
Thank you.
Cheers.
Bye. Bye.
Bye-bye.
Thanks, everyone.